Okay, in this video, we're going to prove the identity f convolved with g equals g convolved with f. And we're going to do this in two ways. The first way is just from the definition and involves a change of variables. So in other words, we'll do the integral tau equals 0 to t f of t minus tau g of tau d tau. Now this is f convolved with g. If we want g convolved with f, the integral needs to be f of t and g of t minus tau. So to accomplish that, we're going to do u substitution, and we're going to say u is equal to t minus tau, and if u is equal to t minus tau, then du is equal to minus d tau. And so what does this integral become? Well, let me change the integrand first. So t minus tau, this will be f of u. If u is equal to t minus tau, this means that tau is equal to t minus u. So this is going to be the integral t minus u. If du is equal to d tau, this means d tau is equal to minus du. And what about the limits? Well, the bottom limit is tau is equal to 0. Well, if u is equal to t minus tau and tau is equal to 0, the bottom limit is going to be u is equal to t. And what does the top limit become? Well, if u is equal to t minus tau and tau is t, u is equal to t minus t, so that's going to be equal to 0. Okay, so notice we've got t in the bottom limit of the integral and 0 in the top, but we also have a minus sign there. So this is equal to minus the integral u equals t to 0, g of t minus u, f of u du, but the minus sign and the limits there can cancel, or really we can switch the limits if you multiply the integral by minus 1, and so this becomes the integral u equals 0 to t g of t minus u f of u du. Okay, but this last integral is just g convolved with f of t. Okay, so the top integral is f convolved with g, the bottom integral is g convolved with f. And so that proves that f convolved with g is equal to g convolved with f. Okay, so now I'm going to prove that same thing, but using two facts about the Laplace transform. The first fact is, remember that the Laplace transform is 1-to-1, meaning that if the Laplace transform of f1 is equal to the Laplace and transform of f2, this implies that f1 is equal to f2. And of course, if f1 is equal to f2, then this implies that the Laplace transform of f1 is equal to the Laplace transform of f2. Okay, that's the first fact. We already know that fact. The other fact is the new fact, which is the Laplace transform of f star g is equal to the Laplace transform of f times the Laplace transform of g, or if we write that with capital letters, this is f times g. Okay, so how can we use these two facts, to prove that f convolved with g is equal to g convolved with f? Well, what we're going to do is we're going to show that the Laplace transform of f convolved with g is equal to the Laplace transform of g convolved with f. Okay, because if that's true, this fact tells us that f convolved with g is equal to g convolved with f. So assume that this fact is true, then using this fact, this lets us imply that f convolved with g is equal to g convolved with f, which is exactly what we're trying to prove. Okay, so now how can we prove this fact? Okay, so the Laplace transform of f convolved with g is equal to f of s times g of s, but this is just multiplication, and f times g is equal to g times f. So this is g of s times f of s. Okay, but now using this fact right here, we have g first in the product, this is equal to the Laplace transform of the convolution G convolved with F. Okay, and so this chain of equalities, if I bring this down, this chain of equalities tells us that the Laplace transform of F convolved with G is equal to the Laplace transform of G convolved with F, and then we use this fact right here to conclude that F convolved with G is equal to G convolved with F.